Okay, we're starting section 4.5, problems in three dimensions. One strategy that I have with problems in three dimensions is to actually view the three-dimensional object. So we're going to look at example 1. So you can read through the example, pause the video right now and read through it. Then we have the illustration here. Okay, Sam's house, Elena's house. We have the base triangle with 1,200 meters in between, etc. So what I've done is I've taken some three-dimensional, well, not three-dimensional, I cut out some triangles and I've illustrated this situation using these triangles. Okay, so you can see in my illustration that the height of the antenna is actually the height of these blue triangles, so I've labeled it with an H. The yellow base triangle, you can see the 1,200 meters along the one side and the 50 degrees as labeled in the original illustration. Well, all I have to do is lay these triangles flat and I can see a two-dimensional illustration of this three-dimensional problem. Okay, there's my three triangles. There's the three triangles in the illustration. All I've done was lay them flat. Notice now, this blue triangle has absolutely no information on it. Okay, with no information, we can't use that triangle. We're going to focus on these two triangles. This yellow triangle is a right triangle. You can see it in the illustration again. There it is in the corner. We have to assume, because that is an antenna, which would come straight up from the ground, that these blue triangles are also right triangles. Even though I'm not using this triangle, I labeled it with a right angle. Okay, so if I have a right triangle, then I can use silly old Henry carried a huge tub of apples. With right angled triangles, I can use SOHCAHTOA. So what I need to decide is what kind of SOHCAHTOA I'm using. Am I going to use sine, cos, or tan in order to solve a problem like this? Well, notice if I'm trying to find the height of this blue triangle, all I have is an angle measurement, 12 degrees. And I've labeled this side X. Prematurely, by the way, but I'll show you why I labeled it X. But in this yellow triangle, we have a 50-degree angle and 1,200 meters along this side. Whenever we have an angle and another side length, SOHCAHTOA will allow us to find any side length on this triangle that we want to find. What we want to do is we want to find this side length, because this side length is exactly the same length as the base of this blue triangle. If we know the base of the blue triangle, then we have a side length and an angle, and that will allow us to find the unknown quantity, which is side H. So we're going to focus on this yellow triangle first of all, and we're going to find side X. If we're trying to find side X, then we need to label this triangle according to SOHCAHTOA. This would be your eyeball here at your 50-degree angle. It's looking across to side X, which would be labeled your opposite side. The square points to the hypotenuse side. And this side, which was adjacent to this triangle anyway, and this 50-degree angle, this is the adjacent side, it has no information on it, nor do we need any information on that part of the triangle. We're focused on finding X, which is attached to this side. So to find X, then we have to use opposite and hypotenuse, which of course is sine. So we're going to set up our sine ratio. Here we go. Sine of 50 degrees equals the opposite side length, which I labeled X, over the hypotenuse side length, which I labeled H, and it is 1,200. So to solve for X, I just simply have to multiply both sides of this equation by 1,200. Bear with me here. It's hard to write and hold the phone at the same time. So X equals 1,200 times sine 50. If I put that into my calculator, I would get 919.2533317. Okay. I want to use as many decimal places as possible. I don't want to round too early, because rounding too early will take away from my true answer at the end. my true answer is not finding x. My true answer is finding h. Now that I have x, I have the x in my blue triangle as well because they are the same side. So I know that x is 919 meters approximately, 919.253317. Now that I have that side length and I have an angle measurement, I can find h. Put my yellow triangle away, focus on my blue triangle. Okay, according to my blue triangle, again I have an angle measurement. This is where my eye would be. I have to look across at the triangle. I see that this is going to be my opposite side here. Ho, 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 ho. Interesting. 12 degrees is attached to my adjacent side. So that's going to be adjacent. And the square points to the hypotenuse. No information on the hypotenuse, and I don't need to find any information on the hypotenuse. I need to find h, and I already know x, which is right here. So what trig ratio relates this 12 degrees with O and A? Well, you can see it right here, tangent. Okay, we're going to set up a tan ratio. Tan of 12 degrees equals opposite side, which I have labeled as an h, over the adjacent side, which I have as x, 919.25, etc. Well, in order to solve for h, I'm going to multiply both sides of my ratio by 919.25, etc., times tan of 12 degrees. Well, I should already have that number stored on my calculator. It's the last answer that I put in there. So all I have to do is multiply by tan of 12 degrees, and I get an answer of 191.12. Take a quick look back at our question. Determine the height of the antenna to the nearest meter. So, therefore, I'm looking at approximately 191. Okay. Therefore, statement. Okay, you can write that on your own. Therefore, the height of the antenna is 191 meters. Okay, but you can see from the problem, it's not always handy to cut these out because it takes time. But maybe for the first few, you just need that visual. It's always good to have, with 3 dimensions, being able to turn your problem into 2 dimensions and relating it to something that you're familiar with.